Karibu Savannah Robotics, and today again we'll be looking at my contraption here. Tuone, so far nimefika wapi naye, so that we could at least discuss a bit about it. So I've taken out the sandbags, as you can see. This is a set to protect the motors. They were in here like this. If you've seen, how to place them in here, and here, let's see, like that. Yeah. And then we put that rubber band. This will protect motor from damage, usually mostly from dust, probably spilling of glue and stuff like that when you're working on contraption. So inatumika ku protect from that. Like super glue now would damage this almost permanently if you do touch it the wrong way. A lot of dust would mean that you need to clean this up. So that is what you're protecting against when you use such bags. They're cheap and they come in handy, and they could do the job. Yeah, like you can see this is super glue. Yeah, so one of the motors was saved from this super glue. Yeah, that's it. Now, so they're off, 4 of them. So as you can see, the motors that I have used are very reliable and can take heavy duty. The A2212 13T 1000 kV motor is one very reliable motor. It can carry both less than 1045 probes and a bit more than that. So that is why I chose this, because if I wanted to use larger probes, heavy lifters, it could allow me a bit to go high. I intend to use 1045 props, but I will also try to get to a little bigger props than that, but that's later. I've used 4 of them here. You have to match all the 4 props for this to work. If you don't, you have a lot of load. It won't work well. And then there is the Simong. This is an electronic speed controller. The electronic speed controller it acts like the interpreter of what you want to do with your quadcopter. So it interprets what you want to do from the signal that is coming in from your transmitter. This is the unit that is used to interpret that. I've used a 30 amp Simong ESC. I've used 4 of them. I've glued them on a sticker chip using super glue so that they stay stuck. If you remember very well, the configuration on the first quad was somewhere here. I wanted the propellers to cool them as it well, but I realized later the cable was a bit short, so I had to change that and put that here. So that is why in the my first configuration was here, but now I've changed them and put them here. And then there is in the middle here, there's a lot of work going on in the middle. You realize that my cables have been intertwined. There's a reason for that, but we'll come to that later. In the middle here, there is where the work is at. You'll see that there is a flight controller in the middle. Up and down, there's a lot of work that is going on. This is the brain of the quadcopter. It is the flight controller. It is the open pilot flight controller, the one you're seeing on your screen. It is a reliable and very functional unit. It works. It's called open pilot because you can configure it in various ways. If it's a helicopter, boat, a submarine, and quadcopter, hexa, it can work very well. So it's an open source unit. Configuring it is not very hard. Not the easiest, but not very hard. If you configure it right, it works. If you don't, you still have parameters in which you can change it. So that is the advantage of using OpenPilot as a starter. As a beginner, it can work a lot well. What OpenPilot does not have is altitude hold. Yeah, so there'll be no altitude hold with this. It won't give you that, and mileage telemetry. But other than that, it works pretty well. And then it is connected to the receiver here. And the receiver here is an FSIA6. This is a receiver that is compatible with its own radio. You'll see later, as I'll try to explain. It's compatible with its own radio, and it works pretty well with its two antennas here. So I've connected that. There's a formula that has been used there. We'll talk about it a bit later. And yeah, also super glued it down here so that it is well stuck. I talked earlier about the cables. The cables are put as such so that they tend to occupy lesser space instead of coming down straight. It would have been difficult, so that is why you see that oval ring there. The contraption is all based on a plastic frame, PVC pipe, double here on the ends, and then single, and then I've screwed that on a clipboard, regular clipboard that is used for doing examinations. And then there's this here. This is the GPS mast. I'm yet to figure out which one I will use. So the GPS mast will be, most of the time it will be down because I've not yet figured which GPS I want to use. So I'll not talk much about that. And then let us look at the underside of it. So I'll come back and then we'll look at it. So I'm back again. Let us look at the underside. Nimesha turn. Sahid is the lower side. So on the underside, kuna series ya batteries imewekwa. The batteries that I've put. And a jugular vein of cables here. So I'll take this and put them apart before we get there. So hapa kuna two sets of units. Unit 1 serves these two motors. The first unit of 6 cells serves these two motors. So you can assume this is a 6S iron batteries. All of them have been identified. You can see a U1 or etc. All of them have been identified. There's an I here so that I can know which one is which. I harvested them from laptop batteries that have been used from the good ones. So this unit here of 6 cells serves these two terminals, motors. And this one obviously serves this other end. Why did I do that? To reduce the surge of batteries. If I had used what would seem like a 12S, I would burn the ESCs. So the electronic speed controllers remain safe with a 6S. When you add more capacity to that, it either does not work, there's no that beeping voice. So I just decided that I need to work with 2 units of cells. There is something else here that I've done, but I'll talk about it later. So it's only batteries here at the bottom, and then of course there are connectors. So this unit is connected by XT60s, and this other unit is also connected by a modified version of a classical connector used for RC cards, but will still work here. So that is that, and asante. So in conclusion, there's a lot of work that goes into making a quadcopter or a copter of any sort, and in fact most of the work involves just getting the parts, sourcing them na kuzipata in Kenya, in my country, and in Nakuru specifically, the city. Inakuwa a lot of work. Sometimes most of these parts are not around. Sometimes they are around. I get them from startup companies that are around, but at other times I have to import them. So if there's a challenge that I've had, it is sourcing. So it has taken a little bit more than 2 years to get all those parts integrated together so that I can start work on my contraption. But other than that, I think the project has gone pretty well. There have been a few changes. Would I have loved it to have gone a different way? Perhaps. But then again, the changes were necessary as at the time that they were being had. So sina complaints mingi about that. But ningewish to that if there's anybody mwenye ngetaka kujoin in the project, there's a bit of time remaining, kama 2 weeks. They can holler me up on my number and join up. Niko very willing to take in anybody that's positive. Thank you.